Hi and Assalamualaikum. My name is SAHHIRRA binti Mustafa. My metric number S52471. I'm going to present about the hydrothermal carbonizations. The definition of hydrothermal carbonization is a process in which biomass is subjected to elevated temperature in aqueous medium confined system. Two product streams are created: one insoluble colloid product and two water-soluble product. The design of HTC technology is in the fig that the water content of biomass is 80% and is pressure before entering the reactor. The HTC process is carried out the aqueous condition at 180 to 150 degrees Celsius at autogenous pressure. For the production of solid biofuel, the processed water can be reduced to 50% by chemical dewatering. After the further thermal drying to water content below 5%, the HTC carbon can be pelletized. Apart from the fact that any inocellulosic biomass can be processed, these aqueous conditions are the most significant advantages of the transformation, since biomass always contain water up to between 50% and 90%. For the HTC process, biomass does not have to be dried by means of energy-consuming thermal process. As the rickety structure of the inocellulose is partly destroyed during this process, physical dehydration is facilitated for the solid product after the process. Hence, mechanical dewatering is possible down to below 50% weight, and the thermal dry can be eliminate the rest of the water. The chemical dewatering saves energy, since it is much less energy consuming than terminal drying, as the water does not have to be evaporated. In illustrate how the energy saving occur, the water content that has been evaporated for the same dry matter is reduced to 1/4 mechanical means. Consequently, the transformation of biomass in the HTC process can be considered as the concentration of the carbon content in the biomass by chemical and physical post-treatment dehydration. The 5 key points about the operation. Hydrothermal carbonization is a thermal chemical process for the pre-treatment of high moisture content biomass under hot compressed water. It is performed in a closed reactor at a temperature range of 180 to 180 degrees Celsius under pressure 2 to 6 mpb for 5 to 200 minutes. The mechanism for this process mainly entails decarboxylation, dehydration, and polymerization. Functional carbonous material can be produced via dehydration and polymerized in the low temperature hydrothermal carbonization process below 300 degrees Celsius. The carbon content is increased during the carbonization phase. The content of the oxygen and mineral matter is decreased with a mineralogenous product. Reaction, temperature, pressure, and time are important factors that influence the process of hydrothermal carbonization. The key product from HTC technology is through the process hydrothermal carbonization HTC, biomass and other residuals are subjected to higher temperature and pressure in the presence of the water, which result into main product, a cool-like product, which is a hydrochar, and a water-soluble product, which is biol. At the pace the biomass go through the mechanical dewatering, the production of solid biofuel are produced when the water has been reduced to 50%. After thermal drying to a water content below 50%, the hydrochar are produced. During the mechanical dewatering phase, the separations between a liquid and solid happen, which is for the solid content like amino sulfate, calcium oxide, potassium hydroxide, and the solid, which is biochar, heavy metal more than 50% and phosphate more than 50%. The type of aquaculture waste that's suitable to be treated by the hydrothermal carbonization is fish waste comprised of head, tail, viscera, fins, and scale from a variety of fish, and microalgae has a biomass structure for HTC. Why suitable? First, for fish waste, study by the Kana et al. 2070 reported that a hydrochar produced from fish waste have quality element composition, proximate composition, morphological structure, and energy value comparable to one of product from the low-grade inocellulosic waste and meat waste. First, can be used as a cold substitute. Secondly, the microstructure of the hydrochar, particularly once of the products at higher holding temperature, suggests that the hydrochar is porous and could be treated for adsorbent and sequestration purpose. And for the second is microalgae. Algae are the most efficiency photosynthesis plants per unit of mass during the growth period that can be double their bulk in the litter has a 3 to 4 hours, and short reaction time will be facilitated by small size a few micron. And next is protein, lipid, carbohydrate, and nucleic acid. Makeup algae has a opposite to lignin, hemicellulose, and cellulose, which are found at higher plant. And lastly, macroalgae should be become an industry community in terms of price and available as the algae all business grow. So that is my reference that I refer for